Hello friends, in this video we will see board question asked from March 1996 to 2024 with solution. I will explain all the examples in a very simple language. Weightage for differential equation in board exam is 8 marks, and simultaneously I will give the link of my video 6.1 to 6.6 and miscellaneous exercise in the description box so that it will help to you to improve your marks. Now let us start. Now the first question, multiple choice questions. The integrating factor of linear differential equation dy by dx plus y into sec x is equals to tan x is. Okay, first option is sec x minus tan x, b sec x into tan x, c sec x plus tan x, and d sec x into cot x. Now we'll see the solution. Okay, now dy by dx plus y into sec x is equals to tan x. This is of the form, which is the form dy by dx plus py is equals to q. Here p is equals to sec x and q is equals to tan x. But what is the integrating factor? Integrating factor is equals to e raised to integral p dx. The value of the p is a sec x. Therefore, e raised to integral sec x into dx. But what is the integral of sec x? That is log of mod of sec x plus tan x. And overall, you will get here, that is the if, that is the integrating factor, is equals to sec x plus tan x. The value of, that is the e raised to log of sec x plus tan x to the base e is nothing but sec x plus tan x. And hence, option C is the correct here. Okay, now next question. The differential equation of the family of the curves y is equals to c1 e raised to x plus c2 e raised to minus x is. The first option A is d2y by dx square plus y is equals to 0. B d2y by dx square minus y is equals to 0. d2y by dx square plus 1 is equals to 0. And D d2y by dx square minus 1 is equals to 0. Okay. Now here there are the two arbitrary constants, and hence it is clear that the order of differential equation is 2. Now here y is equals to c1 e raised to x plus c2 e raised to x. Now differentiate this with respect to x. Therefore dy by dx is equals to derivative of e raised to x is e raised to x, and derivative of e raised to minus x is a minus e raised to minus x. And second derivative again, that is a c1, again derivative of e raised to x is e raised to x, again derivative of e raised to minus x is a minus e raised to x, and this minus and minus, that will become plus. And hence d2y by dx square is equals to c1 e raised to x plus c2 e raised to minus x. But what is this? This is nothing but y. Okay, now we will shift this y towards the left hand side and it will become minus. Therefore d2y by dx square minus y is equals to 0. Okay, and hence option B is correct here. Now next question. The solution of the differential equation dy by dx is equals to sec x minus y tan x is. Okay, now the first option is y sec x is equals to tan x plus c. B is y sec x plus tan x is equals to c. C option sec x is equals to y tan x plus c. D option sec x plus y tan x is equals to c. Okay, now let us see the solution. Dy by dx is equals to sec x minus y tan x. Dy by dx plus y tan x is equals to sec x. This is of the form again, dy by dx plus py is equals to q. Here the value of p is a tan x and q is a sec x. Okay, Now the integrating factor is equals to e raised to integral of p dx. Okay, but what is the p? P is a tan x. Therefore, e raised to integral of tan x is nothing but log of sec x. Again here, e raised to log of sec x to the base e is nothing but the sec x, and hence integrating factor is a sec x. Now we'll see the solution of this differential equation. Solution of the given equation is of the form. What is that form? Y into if is equals to integral q into if means what, integrating factor into dx plus c, and therefore the integrating factor is a sec x. We'll substitute the value. Y into if means what? Y into sec x is equals to integral. Q means what? Sec x. If means sec x plus c. Now here sec x into sec x means what? Sec square x. Okay, into dx. Okay, here the dx and again here the dx. Now integral of sec x is a sec square is a tan x. Okay, therefore y sec x integral of sec square dx is a tan x and plus c, and hence this is the solution. Hence option A is a correct here. Next question. Order and degree of the differential equation in bracket square bracket 1 plus dy by dx bracket raised to 3 whole bracket raised to 7 by 3 is equals to 7 in bracket d2y by dx square r respectively. Okay, now see this here. The order and degree means what? First is option here is the order and the second number is the degree. A is a 2 3, B is a 3 2, C is a 2 2, and D is a 3 3. Now we'll see this equation, that is in square bracket 1 plus dy by dx bracket is to 3 and whole bracket is to 7 by 3 is equals to 7 into d2y by dx square. Now take cube on both sides. Okay, therefore to find out the order and the degree, therefore it must be free from the radical sign. Therefore cubing on the both sides, then you will get here 1 plus dy by dx bracket is to 3. If you take the cube on both sides, it by multiplied by 3, 3 will get cancelled, and here you will get a bracket is to 3. Okay, and hence here the order of the differential equation is a 2 here and the degree is a 3. Okay, and hence the option A is a correct here. The order and the degree of the differential equation d3y by dx cube raised to 1 upon 6 minus dy by dx raised to 1 by 3 is equals to 0 r respectively. Okay. Now the first option, A is a 3 2, B is a 2 3, C is a 6 3, and D is a 3 1. Now the solution, d3y by dx cube raised to 1 by 6 minus dy by dx bracket raised to 1 by 3 is equals to 0. Okay. d3y by dx cube raised to 1 by 6 is equals to dy by dx raised to 1 by 3. Okay. Taking sixth power on both sides, then you will get here. If you take the sixth power on both sides, that is a multiplied here 6 and here 6. Then you will get here the 6 will get cancelled. 3 1s are 1, 3 2s are 6. That is the dy by dx bracket is to 2 is equals to d3y by dx cube. Okay, and hence here the order of the differential equation is 3 and degree is 1. Okay, hence option D is correct here. Now the next question, if y is equals to e raised to a into e raised to 5x plus b into e raised to minus 5x. Okay, then the differential equation is, okay, the first option A is d2y by dx square is equals to 25y, b d2y by dx square is equals to minus 25y, d2y by dx square is equals to minus 5y, and d3y by dx square is equals to 5. Now here again there are the two arbitrary constants. We will differentiate these two times. Now the first differentiation, dy by dx is equals to the derivative of e raised to phi x is e raised to phi x into derivative of this phi x. Derivative of this phi x is a phi. Therefore, derivative of e raised to phi x is a phi u into e raised to phi x. This constant a is as it is. Now again the derivative of e raised to minus phi x. Derivative of e raised to minus phi x is e raised to minus phi x, and the derivative of e raised to, that is a minus phi x. Derivative of minus phi x is a minus phi. Okay, this is the first derivative. Again differentiate this with respect to x. d2y by dx square is equals to, again the derivative of e raised to phi x is a phi into e raised to phi x. Phi into phi, 25. Constant a is as it is, e raised to phi x. Again, derivative of e raised to minus phi x is a minus phi u e raised to minus phi x. Again, the minus phi into minus phi, that will become 25u b e raised to minus phi u x. Okay, and hence here d2y by dx square. Okay, we can take here 25 as a common. In bracket, a into e raised to phi x plus b into e raised to minus phi x. Okay, and this is nothing but 1. Therefore, d2y by dx square is equals to 25u 1. Okay, and hence option A is a correct here. Now next question. The differential equation whose general solution is y is equals to log x plus c is. Okay, now these are the options. First option A is x into dy by dx is equals to 1. B is x into dy by dx plus 1 is equals to 0. C is dy by dx plus x is equals to 0. And D is 1 upon x into dy by dx is equals to 0. Now here the arbitrary constant is 1. Therefore the order of this differential equation must be 1. Now see this here, y is equals to log x plus c. Differentiate this with respect to x. Derivative of log of x is 1 upon x. Derivative of c is 0. Therefore, x into dy by dx is equals to 1. Okay. And hence here the option A is correct. Now next, order and degree of differential equation d4y upon dx raised to 4 is equals to, in square bracket, 1 plus dy by dx bracket square raised to whole bracket raised to 3 respectively are. Okay, now here the order is 1, degree is 4, first option. B order 4, degree 1. C order 6, degree 1. And the D order 1 and the degree 6. Now here it's a clear that the radicand or the brackets are the positive numbers, that is a natural numbers, positive integers. Therefore here the order is 4 and the degree is 1, and hence option B is correct here. Next, the differential equation of y is equals to c upon x plus c square is. Okay, this question asked in March 15 and July 22 examination. These are the all options A, B, C and D. Okay, now we'll differentiate this. Okay, y is equals to c upon x plus c square. Again here the arbitrary constant is 1. Therefore, the order must be 1. These two options will not possible. Only these two will be the possible. For that we will differentiate this. Differentiate with respect to x. Here the derivative of c upon x is a c into minus 1 upon x square. Derivative of c is a 0. Next, therefore c is equals to minus x square into dy by dx. Substituting the value of c in 1. Therefore substitute the value of c in 1. And then you will get here y is equals to 1 upon x. The value of c is a minus x square into dy by dx plus. Next is a x raised to 4. Okay. Now here the value of the c square, that is a squaring on both sides. C square is equals to x raised to 4 into, in bracket, dy by dx bracket square. Therefore y is equals to 1 upon x into, in bracket, minus x square into dy by dx plus x raised to 4 into dy by dx bracket square. And then after simplifying, you will get here y is equals to x raised to 4 dy by dx bracket square. Now again here simplification, minus x into dy by dx, and hence the required differential equation is a x raised to 4 into dy by dx bracket square minus x into dy by dx is equals to y, and hence option A is the correct here. The solution of the differential equation dx upon dt is equals to x into log x upon t is, okay. Now the first option A is a x is equals to e raised to ct, b is a x plus e raised to ct is equals to 0, c is a x is equals to e raised to t plus t, and d is a x into e raised to ct is equals to 0. Okay, now here dx upon dt is equals to x log x upon t. Now here we'll separate the variable. In short, we'll take this x into log x to the denominator of the dx and take this dt to the RHS, then it will become dt upon t. Okay, now integrating on both sides, this is the differential equation is of the type variable separable method. With the help of variable separable method, we can solve this differential equation. Now integrating on both sides, then you will get here dx upon x log of x is equals to integral of dt upon t. Integral of dt upon t is nothing but log of t. But what about here integral of dx upon x log x? Here we will apply the substitution, log of x is equals to t. Okay, log of x is equals to t. Then it's a derivative, that is a 1 upon x into dx is equals to dt. Our integral will become dt upon t. Okay, hence this integral is a log of t is equals to this log of t. Okay, therefore here that is a log of log x is equals to log of mod t plus log of c. We will replace the here the value of the t. What was the value of the t? T is a log x. Therefore, the integral of dx upon x into log x is log of log x is equals to log of mod of t plus log of c. Now the next, log of log x is equals to, now the product of these two, log of m plus log of n is equals to log of m into n. Log get cancelled on both sides, then you will get here log of x is equals to ct. Okay, therefore x is equals to e raised to ct, and this is the solution, and hence option A is a correct here. Next, the differential equation y into dy by dx plus x is equals to 0 represent family of circle, b parabola, c ellipse, d hyperbola. Okay, now we see this here, the solution y into dy by dx plus x is equals to 0. Now next, again here we will apply the variable separable method. That is first, that is a y. If we multiply on both sides by dx, then what you will get here? That is a here dy by dx is equals to minus x, and then y into dy is equals to minus x into dx. Now take this term to the left hand side, it will become plus. Therefore, integral x into dx plus integral y into dy is equals to 0. Integrating both sides, then you will get here x square upon 2 plus y square upon 2 is equals to c square, which is the constant. Okay, therefore x square plus y square is equals to 2c square, which represent a circle. Okay, and hence this equation represent family of circle, and hence option A is a correct here. Now next, the integrating factor of linear differential equation x into dy by dx plus 2y is equals to x square log x is. Okay, this question asked in March 18 and 24 examination. First a is x, b is 1 upon x, c is x square, and d is 1 upon x square. Now we'll see the solution. dy by dx plus 2 upon y into y is equals to x log x. This is of the form dy by dx plus py is equals to q, where the value of the p is a coefficient of y, means of 2 upon x. Okay, therefore integrating factor is equals to e raised to integral p dx. The value of p is a 2 upon x, e raised to integral 2 upon x dx. The derivative integral of 1 upon x into dx is a log x. Therefore, e raised to 2 log x. Okay, and it can be written as e raised to log of x square. Again, e raised to log of x square to the base e is nothing but x square, and hence the integrating factor is x square, and hence option C is correct here. And in this way, here we have completed all the multiple choice question. Now we will see question based on exercise 6.1, 6.1, which asked in board examination. Now questions based on exercise 6.1. Okay. Now here, first example. Write the degree of the differential equation y. Yeah, here there are the three dots, bracket square, plus 3y dash dash plus 3xy dash plus 5y is equals to 0. This question asked in March 22 examination. Now here in highest order derivative is y, and here 3 dash means what? Third order derivative, and its a degree is 2. We consider always the higher order derivative and its a degree. Here higher order derivative is 3 and its a degree is 2. Okay, that is a d3y upon dx cube with power 2. Therefore, by definition of order and the degree, that is order is 3 and degree is 2. Okay. Now next, write the degree of the differential equation dy by dx plus 3xy upon dy by dx is equals to cos x. This question asked in July 22 examination. dy by dx plus 3xy upon dy by dx is equals to cos x. For this simplification, multiply on both sides by dy by dx. If you multiply here dy by dx into dy by dx, then it will become dy by dx bracket square plus 3xy upon dy by dx into dy by dx. Then dy by dx will get cancelled. You will get here 3xy is equals to cos x into dy by dx. Here, again the order is 1 and degree is 2. Okay, degree is 2. Now, next question. Write the degree of the differential equation dy by e raised to dy by dx plus dy by dx is equals to x. This question asked in March 23 examination. Since the given differential equation cannot be expressed as a polynomial in differential coefficients, therefore the degree is not defined. Okay. Now next, questions based on exercise 6.2. Okay. Now here the first question. Obtain the differential equation by eliminating the arbitrary constant a, b from the equation. Y is equals to a cos of log x plus b sin of log x. Okay. Now here the two arbitrary constant a and b. Therefore, we must differentiate this two times. Now first y is equals to a cos log x plus b sin of log x. First differentiation. Differentiating with respect to x, then you will get here dy by dx is equals to derivative of a cos of log x. Its a derivative is minus a sine of log x, and derivative of log of x is 1 upon x. Okay, therefore, the derivative of a cos of log x is a minus a sine of log x upon x. Again, the derivative of this sin x is a cos of log x, but it is a composite function. Derivative of log x is a 1 upon x. Okay, this is the first one. Now next, multiplying on both sides by x, then you will get here dy x into dy by dx. If you multiply dx, x and z cancel. Then you will get here minus a sine of log x plus, again x and z cancel, plus b cos of log x. Next, again differentiate this with respect to x. X into dy by dx, it's a derivative, x as it is. Derivative of dy by dx is a d2y by dx square. Here we will apply the product rule. Next, derivative of x is 1 into dy by dx is equals to, again the derivative of this term. Again the derivative of sine of log x is a cos of log x upon x minus derivative of cos x log x is a minus, okay, sine of log x. Again the derivative of log x is 1 upon x. Again you are multiplying on both sides by x, then you will get here x into x square d2y by dx square plus x into dy by dx is equals to minus, if you take the minus sign as a common, then you will get here a cos of log x plus b sine of log x. Okay, but what is this? This is nothing but y, and hence x square d2y by dx square plus x into dy by dx is equals to minus y. Okay, and hence the final differential equation is a x square d2y by dx square plus x dy by dx plus y is equals to 0. This is required differential equation. Next, if y is equals to e raised to x, then show that x into dy by dx is equals to y log of y. Okay, this is a differential equation. Now your arbitrary constant is a only. Okay, therefore first y is equals to e raised to log x. This exponential function can be converted into the log function. Therefore you will get here log of y is equals to ax. Okay, this is the first one. Now differentiate this with respect to x. Derivative of log of y is a 1 upon y, and y is a dy by dx. Derivative of ax is a. Derivative of x is 1. Therefore 1 upon y into dy by dx is equals to a. This is the second one. Okay. Substituting the value of second in 1. Here we will substitute the value of a in this equation. Then you will get here log of y is equals to, what is the value of a? Here we will substitute the value of a. A is 1 upon y into dy by dx into x. Okay. Therefore, then you will get here that is the x into dy by dx is equals to y log y. Take this y to the left hand side, then it will become y log of y. Okay. And this is the required differential equation which we want to show that. Form the differential equation by eliminating arbitrary constant from the relation y is equals to a into e raised to 5x plus b into e raised to minus 5x. Just we have solved this type of example. Here there are the two arbitrary constants. Hence we want to differentiate two times here. Now the first, differentiating with respect to x, dy by dx is equals to derivative of e raised to 5x is e raised to 5x, and derivative of 5x is a 5. Again, derivative of e raised to minus 5x is e raised to minus 5x, and derivative of minus 5x is a minus 5. Now again differentiate this with respect to x, then you will get here d2y by dx square is equals to derivative of, here the 5 is a constant, ddx of e raised to 5x minus 5 will be ddx of e raised to minus 5x. Derivative of e raised to 5x is again 5 into e raised to 5x. Derivative of e raised to minus 5x is a minus 5 e raised to minus 5x. Minus minus will become plus. 5 into 5, 25a e raised to 5x plus 25b e raised to minus 5x. Take 25 as a common, then in bracket you will get here a into e raised to 5x plus b into e raised to minus 5x. But what is this? This is nothing but y. Therefore, d2y by dx square is equals to 25y. Okay, and this is the required differential equation. Now, next, Obtain the differential equation by eliminating the arbitrary constant from the following equation. Y is equals to C1 e raised to 2x plus C2 e raised to minus 2x. Same type of examples. Again differentiate this 2 times. Derivative of e raised to 2x is a e raised to 2x into derivative of this 2x, which is 2. Again derivative of e raised to minus 2x is a e raised to minus 2x into derivative of minus 2x is a minus 2, and hence here we write here minus 2. Okay, and hence this is the dy by dx is equals to 2c1 e raised to 2x minus 2c2 e raised to minus 2x. Again differentiating with respect to x. Okay, d2y by dx square. Derivative of e raised to 2x is a 2 e raised to 2x minus 2c2 ddx of e raised to minus 2x, 2cx e raised to minus 2x. Again it's a derivative is a minus 2 e raised to minus 2x. Minus minus will become again plus. Okay, therefore you will get here 4c1 e raised to 2x plus 4c2 e raised to minus 2x. If I take 4 as a common, then in bracket you will get here c1 e raised to 2x plus c2 e raised to minus 2x, and this is nothing but y. Okay, and hence d2y by dx square is equals to 4y. Okay, and hence d2y by dx square minus 4y is equals to 0. This is a required differential equation. Form the differential equation of all lines which makes intercept 3 on x, okay, axis, which makes intercept 3 on the x-axis. I will change here x-axis. Okay, now here let the equation of all lines which makes intercept 3 on x-axis be. Now if you take the coordinate geometry, simple. Okay, it makes an intercept on the x-axis as a 3. Means what is the coordinate of this point? That is a 3 comma 0. If m is the slope of the line, then its equation, that is a y minus y1. What is the y1? y1 is 0 is equals to m in bracket, that is a y minus y1 is equals to m in bracket x minus x1. The value of y1 is 0 and x1 is 3. Therefore y minus 0 is nothing but y is equals to n in bracket x minus 3. Okay. Now the next, differentiate this with respect to x, then you will get here dy by dx is equals to m. The derivative of x is 1, derivative of 3 is 0, therefore dy by dx is equals to m. Now substitute the value of this m here in the equation 1. Therefore you will get here y is equals to, the value of m is a dy by dx into x minus 3. Okay, and this is the required differential equation. Now next, obtain the differential equation by eliminating the arbitrary constant from the equation y square is equals to 4ax. Now here arbitrary constant is a. Now first, a is arbitrary constant, differentiating with respect to x. Derivative of y square is a 2y into dy by dx. Derivative of 4a x, here 4 is a constant, derivative of x is 1. 1 into 4a, 4a. Therefore, the value of 4a is a 2y into dy by dx. Put this value in equation 1. Then you will get here y square is equals to, in the value of 4a, that is a 2y into dy by dx, bracket complete into x. And hence you will get here y square, that here y square is equals to 2y into dy by dx, bracket complete into x. Now cancel on both side y, then you will get here y is equals to 2x into dy by dx. Okay, then shift this term to the left hand side, it will become minus, and hence this is the required differential equation. What is that? Y minus 2x into dy by dx is equals to 0. Here arbitrary constant is single one, and hence the order of differential equation is a, that is 1. Okay, arbitrary constant is 1 and the order of differential equation is also 1. Now next, a particle is moving along x-axis. Its acceleration at time t is proportional to its velocity at that time. Find the differential equation of the motion of the particle. Here, let S be the displacement of the particle at time t. Its velocity and acceleration are, that is the derivative of displacement with respect to time. This is the velocity. And again, the derivative of velocity means what? That is the d2s by dt square. This is nothing but acceleration. Means what? ds upon dt is velocity and d2s by dt square is acceleration. Therefore, according to the given condition, what is the condition? Its acceleration at time t is proportional to its velocity. Therefore, d2s upon dt square is proportional to its velocity, ds upon dt. If we take the k as a constant of proportionality, therefore d2s upon dt square is equals to k into ds upon dt. Okay. And this is the required differential equation. Now next, we'll start the exercise 6.3, that is the question based on exercise 6.3. Now board examples based on exercise 6.3. Now here, first example, solve 3 into e raised to x into tan y dx plus in bracket 1 plus e raised to x bracket complete sec square y into dy is equals to 0. Also find the particular solution when x is equals to 0 and y is equals to pi. This question asked in October 14 examination. Okay. Now all these examples depends on variable separable method. Okay. Now see this here. 3 into e raised to x tan y into dx plus in bracket 1 plus e raised to x into sec square y dy is equals to 0. Now here we will separate the variables here. Okay. Now shift this term to the right hand side. It will become minus. Then here we take this tan of y to the right hand side and 1 plus e raised to x to the left hand side. Therefore, our equation will become, that is the 3 e raised to x dx upon 1 plus e raised to x is equals to minus sec square y upon tan y into dy. Okay. Integrating both sides, we get here. That is a 3 integral e raised to x upon 1 plus e raised to x dx, that's equals to minus sec square y upon tan y dy. Okay. Now this is of the form integration. That is integral f dash of x upon f of x into dx is equals to log of f of x plus c. And similar here, what is the derivative of 1 plus e raised to x? The derivative of 1 plus e raised to x is a e raised to x. What is the derivative of tan y? Is a sec square y. Therefore, it is of the form. And their integration is a 3 log of mod of 1 plus e raised to x is equals to minus log of tan y plus log c. Here we take the constant in the form of the log. Okay. Now next, that is if we take the 3 to the power of this 1 plus e raised to x, then it will become with the help of the rules of log. Therefore, log of mod of in bracket 1 plus e raised to x bracket raised to 3 is equals to. Now see this here. Here is the minus sign. That is a log of m minus log of n. Then you would get log of m upon n. Means what? Log of c upon tan y. Now cancel log sign on both sides or take antilog on both sides. Then you will get here 1 plus e raised to x bracket raised to 3 is equals to c upon tan y. Okay. Now we want to find out the particular solution. And we have given the values of x and y. Here x is equals to 0 and y is equals to pi. If we substitute here, x is equals to 0 and y is equals to pi, then you will get here e raised to 0 is 1, 1 plus 1, bracket raised to 3 into 0, and overall the value of c will be 0, and hence after substituting the value of c in this equation, okay, this is equation number 1. Okay, this is the equation 1. Then our required solution is a 1 plus e raised to x bracket raised to 3 tan y is equals to 0, which is particular solution. Okay, this is equation 1. Now, this will be answer. Next example. Now, second example. Solve the differential equation y minus x into dy by dx is equals to 0. Okay. Now, see this here. That is the shift this term to the right hand side. Y is equals to x into dy by dx. Therefore, dx upon x is equals to, again, apply the variable separable. Take this dx, denominator dx, to the left hand side and take this y to the denominator of this dy and shift this x to the left hand side. Then you will get here dx upon x is equals to dy upon y. Now integrating on both sides, dx upon x is equals to integral dy upon y. Its integral is a log of mod of x is equals to log of mod of y. We take the constant in terms of the log. Okay, that is a log of mod of c. And hence you will have that is a log of mod of x is equals to log of mod of y into c. Now cancel the log sign on both sides, or you can take antilog on both sides. Therefore, you will get here x is equals to cy, and this is the solution. Now next, solve the differential equation x plus y into dy by dx is equals to sec square in bracket x square plus y square, and also find the particular solution if x and y both are 0. Now this is differential equation. Put x square plus y square is equals to u. Differentiate this. Derivative of x square is a 2x. Derivative of y square is a 2y into dy by dx. And the derivative of u is a du by dx. Okay. Now take these two as common and shift these two to the right hand side. Therefore, you will get here, if you take 2 as a common, then what you will get here? That is a 2 in bracket x plus y into dy by dx is equals to, okay, is equals to du by dx. Then shift these two to the right hand side. Therefore, x plus y into dy by dx is equals to 1 upon 2 into du by dx. Now substitute this value in equation 1. Then it will become, what is the value of x plus y into dy by dx? It is 1 upon 2 into du by dx. Okay. Therefore, you will get here 1 upon 2 into du by dx is equals to sec square u. Again, apply the variable separable method. Take this sec u to the denominator of this du and take this dx to the right hand side. Shift this constant also. Integrating on both sides, that is you will get here integral of this, that is the 1 upon sec u means what? Cos u. Therefore, integral of cos of u into du is equals to 2 integral dx. What is the integral of cos of u? It's a sine of u. Integral of dx is the 2x plus c, and substitute the value of u, which is the x square plus y square. Therefore, sine of x square plus y square is equals to 2x plus c. Okay. Now, we want to find out the particular solution. For that, substitute here x and y both are 0 in this equation. Okay. When x is 0, y is equals to 0. You will get here sine of 0 is equals to 0 plus c. And here the value of c is a 0. Sine 0 is 0. It means that c is equals to 0. Substitute here in this equation, that is equation number 4. Then you will get here the required solution, that is the sine of x square plus y square is equals to 2x. This is the required particular solution. Okay. Now next, solve the differential equation cos of in bracket x plus y into dy is equals to dx. Hence find the particular solution when both x and y both are 0. Now see this here, that is the cos in bracket x plus y into dy is equals to dx. Therefore, dy by dx is equals to 1 upon cos of x plus y. Put x plus y is equals to 0. Differentiate this. The root of x is 1, y is a dy by dx is equals to du by dx. Therefore, dy by dx is equals to du by dx minus 1. Substitute the value of this in equation number 1. Okay. Substituting the value of 2 and 3 in 1, then you will get here. Okay. that is the du by dx minus 1 is equals to 1 upon cos of u. And after simplification, take this, shift this minus 1 to the right hand side. It will become du by dx is equals to 1 upon cos of u plus 1. Therefore, du by dx is equals to 1 plus cos of u upon cos of u. Okay. Now, here we will apply the variable separable method. Shift this dx to the right hand side and shift this cos of u and 1 plus cos of u to the left hand side. Then it will become, that is, if you shift this to the left hand side, it will come to the numerator, that is the cos of u, and this will go to the denominator. It means that 1 plus cos of u into du, and shift this to the right hand side, that is equals to dx. Okay. Now here integrating on both sides, that is the cos of u upon 1 plus cos of u into du is equals to integral of dx. Now here we will add and subtract plus 1. Okay. That is the cos of u means what? 1 plus, here written, that is a 1 plus cos of u minus 1. Here we have adjusted plus 1 and minus 1. Okay. So that our integral will be very in simplest form. Upon 1 plus cos of u into du is equals to integral dx. Okay. Now see this here. We have come here. Split up this. 1 plus cos of u upon 1 plus cos of u. You will get here 1 upon 1 minus 1 upon 1 plus cos of u bracket complete into du is equals to integral dx. Next is what is the 1 plus cos of u? By using with the help of the trigonometry, that is the 2 cos square u by 2 bracket complete into du is equals to integral dx. Okay, that is integral in bracket 1 minus 1 upon 2. Now 1 upon cos square u by 2 means what? Sec square u by 2 bracket complete into du is equals to integral dx here. Okay, here is the integral dx. Okay. Now next, integral of 1 is a u. Integral of sec square is a tan of u by 2 upon derivative of u by 2 means what? 1 upon 2. Next, these 2 to get cancelled. U equal to x, integral of dx is x plus c. Okay. And after simplification, you will get here u minus tan of u by 2 is equals to x plus c. Substitute the value of x, u, that is x plus y, minus tan of x plus y upon 2 is equals to x plus c. And again the simplification, that is on the both sides x and x get cancelled. You will get here y, shift this term, that is a minus tan of x plus y upon 2 to the right hand side, and then you will have this solution, that is y is equals to tan of in bracket x plus y upon 2 plus c. Now particular solution. When x is equals to 0, y is equals to 0. If we substitute x is equals to 0, y is equals to 0, then what you will get here? Tan of 0 is equals to 0 plus 0. Okay, that is the 0 is equals to tan of 0 plus c. But what is the tan 0? Tan 0 is 0. It means that the value of c is equals to 0. Substitute the value of c in the equation number 4, and hence you will have, this is the particular solution, that is y is equals to tan of x plus y upon 2, which is required particular solution when x and y both are 0. Now from first you can see this here, and this is the next one. Okay. Solve the differential equation sec square x into tan y dx plus sec square y into tan x dy is equals to 0. Okay. Again here we will apply the variable separable method. Now what is here we are doing? Now for the variable separable, which terms we do not require here? Tan y. And here we do not require tan x. Therefore we divide this whole equation by tan x into tan y. If we add here tan x into tan y get cancelled. You will get here sec square x upon tan x. And what about here? Sec square y upon tan y. Okay, see this here. If you divide by the term tan x into tan y, then you will get here sec square x into tan y upon tan x into tan y dx plus sec square y into tan x upon tan x into tan y dy is equals to 0. Okay. Now tan y get cancelled, and here tan x get cancelled. Integrating on both sides, then you will have, that is again of this form, integral f dash of x upon f of x is equals to log of mod of f of x plus c. Similarly here, what is the derivative of tan x? Is a sec square. Okay, and that's equals to integrating. Therefore here the log of tan x plus log of tan y is equals to, again I will write here first, when we take the integration you must have here c. Okay, and hence we take it as a after the that is a log c. We write here log of mod of c. Okay, again here log of m plus log of n means what? Log of m into n is equals to log c. Taking antilog on both sides, then you will have tan x into tan y is equals to c, and hence this is the solution. Now next, solve dy by dx is equals to cos of x plus y. Put here x plus y is equals to u. Differentiate this with respect to x. Derivative of x is 1, y is a dy by dx, u is a du by dx. Therefore, dy by dx is equals to du by dx minus 1. Now substitute these values in equation number 1. Then you will have, that is, what is the value of dy by dx is a du by dx minus 1. And here, cos of u. Okay, now next simplification. That is the du by dx, shift this minus 1 to the right hand side, it will become plus 1. Du by dx is equals to 1 plus cos of u. Now again apply the variable separable method. That is what, first, what is the 1 plus cos of u? It's a 2 cos square u by 2. Again then shift this 2 times cos square u by 2 to the left hand side. Okay. Therefore you have 1 upon 2 cos square u by 2 into du is equals to dx. Okay. But what is the 1 upon cos square u by 2? That is the sec square u by 2. Okay. Now integrating on both sides, then you will have 1 upon 2 integral sec square u by 2 du is equals to integral dx. Okay. What is the integral of sec square u by 2? It's a tan of u by 2 upon derivative of u by 2. Okay. Integral of dx is x plus c. Now these two will get cancelled. You will have tan of u by 2 is equals to x plus c. But what is the u? U is the x plus y. And hence tan of x plus y upon 2 is equals to x plus c. This is the required solution. Now next, find the particular solution of the differential equation y in bracket 1 plus log x into dx upon dy minus x log x is equals to 0 when y is equals to e square and x is equals to e. Okay. Now here again we will apply the variable separable form. Okay, variable separable type. That is a y in bracket 1 plus log x. Shift this dx to the right hand side. Then you will have, that is a y in bracket 1 plus log x bracket complete into dx is equals to x log of x into dy. Okay. Now which terms we do not require here? That is, here we do not require here y, and here we do not require here x log x. Okay. Therefore, after separating the variables, you will have 1 upon y into dy. Okay, 1 upon y. That is, shift this y to the right hand side. Then you will have 1 upon y into dy. And next shift this x into log x to the left hand side. And overall you will become 1 plus log x upon x log x into dx. Now integrating on both sides. Then you will have here that integral 1 upon y into dy is equals to 1 plus log x upon x log x dx. Now what is the here substitution for this integration? The integral of 1 upon y into dy is a log of y. But for this we take here x log of x is equals to t. Then what's the derivative of log of x? Is 1 upon x. X upon x plus derivative of x is 1, and here log of x bracket complete into dx is equals to dt. X get cancelled. 1 plus log of x bracket complete into dx is equals to dt. Therefore, the value of 1 plus log of x into dx is the dt. Means what? You will have the integral of the type dt upon t. What's the integral? its integral is a log t. But what is a t? T is a nothing but x log of x. Okay, and for solving this integration, you will have log of y log of x into log x. And what about the constant? Constant is also in the form of log. That is a log c. Okay, that is a log of y is equals to. This is log of m plus log of n is nothing but log of m into n. Means or log of c x log x. Taking antilog on both sides, then you will have y is equals to cx log x. This is the first one. Now we want to find out the particular solution when y is equals to e raised to 2 and x is equals to e. Substitute these values in equation number 1. What is the y? Y is e square, x is a, that is a c into e log of e. But what is the value of log of e? Log of e is 1 because here base is 1. Therefore, e square is equals to c. Cancel e on both sides, then you will get your value of the c is equals to e. Okay, now substitute the value of this c in this equation number 1. Then you will have here y is equals to e x log of x. Substituting the c is equals to e, then you will have y is equals to e x log x, which is the required particular solution. Okay. Now next example. Solve the differential equation dy by dx is equals to x square into y plus y. February 20 is question asked in February 20. Now again dy by dx is equals to x square into y plus y. Take y as a common. Okay. Again apply the variable separable form. Shift this y to the left hand side. Then it will become 1 upon y into dy. Next shift this dx to the right hand side. Then you will have in bracket x square plus 1 into dx. Integrating on both sides. Then you will have integral of 1 upon y into dy is equals to integral of in bracket x square plus 1 bracket complete into dx. What is the integral of 1 upon y? That is the log of y. Integral of x square is x cube upon 3. Integral of 1 is x and plus c. Okay. And this is the required solution. Now next. Solve x plus y into dy by dx is equals to x square in bracket x square plus y square. Now put here x square plus y square is equals to u. After differentiating, you will have derivative of x square is a 2x. Derivative of y square is a 2y into dy by dx. Derivative of u is a du by dx. After taking the 2 as a common, and then the equation, shift this 2 to the left and right hand side, then it will become, that is if you take 2 as a common, then you will have x plus y into dy by dx bracket complete is equals to du by dx. Okay, shift this term to the right hand side, then it will become 1 upon 2 into du by dx. Therefore, x plus y into dy by dx is equals to 1 upon 2 into du by dx. Therefore, equation now 1 will become, what is the value of x plus y into dy by dx? Is 1 upon 2 into du by dx. Therefore, if we substitute here x plus y into dy by dx in place of x plus y into dy by dx is 1 upon 2 into du by dx, then equation number 1 will become 1 upon 2 du by dx is equals to sec of u. Again apply here variable separable method here, that is shift this sec u to the left hand side, it will become 1 upon sec u into du, and shift this 2 to the right hand side and dx also, that is a 2 dx, that is 1 upon sec u into du is equals to 2 dx. Okay, integrating on both sides, then you will have, that is what is 1 upon sec u is a cos u into du. Okay, 2 integral of dx. Integral of cos u is a sin u. Integral of dx is x, 2x plus c. Therefore, sin of u is equals to 2x plus c. So, resubstitute the value of u. That is sin of x square plus y square is equals to 2x plus c. This is general solution. Okay. Now, next example. Solve the differential equation y into dy by dx plus x is equals to 0. Again, shift this x to the right hand side, it will become minus. Again, apply the variable separable form. Shift this dx to the right hand side, then it will become y dy is equals to minus x dx. Integrating on both sides, then you will have integral y dy. Shift this minus x dx to the left hand side, it will become plus, and taking the integral on both sides. What is the integral of y? That is y square upon 2. Integral of x is a x square upon 2, and here is the constant c1. Multiply on both sides by 2, then you will have y square plus x square is equals to 2c1, and this is the 2c1 is equals to c, and this is the required solution, that is x square plus y square is equals to c. Now next, solve the differential equation x plus y into dy by dx is minus 1 is equals to 2 times e raised to minus y. Also find particular solution when x is equals to 1 and y is equals to 0. Okay. Now first of all, shift this minus 1 to the right hand side, it will become plus 1. That is, in bracket x plus 1 into dy by dx is equals to 2 upon e raised to y plus 1. Okay. Now next, after simplification of this, that is e raised to y into 1, then you will get a 2 plus e raised to y upon e raised to y. Okay. Now again apply the variable separable method, that is a e raised to y upon 1 plus, that is a 2 plus e raised to y into dy. Shift this x plus 1 to the right hand side, then you will have dx upon 1 plus x, that is apply the variable separable method. Okay. Integrating on both sides, again it is of the form f dash of x upon f of x is equals to log of mod of f of x. That is integral here e raised to y upon 2 plus e raised to y. What is the derivative of 2 plus e raised to y? Is e raised to y. Therefore it is of this form. Similarly here, integral dx upon 1 plus x. Derivative of 1 plus x is 1. Again here f dash of x upon f of x. And hence, integral is a log of mod of 2 plus e raised to y is equals to log of mod of 1 plus x plus log of mod of c. We have taken this constant also in terms of log form. Okay. For the next simplification. Now next here, log of mod of x plus 1 plus x plus log of mod of c is nothing but that is the product of these two. Okay, log of m plus log of n is nothing but log of m into n. Similarly here, log of mod of c into in bracket 1 plus x. Now taking antilog on both sides, or all log get cancelled on both sides. 2 plus e raised to y is equals to c in bracket 1 plus x. When y is equals to 0, x is equals to 1, then you will have, that is a 2 plus y is 0, that is 2 plus e raised to 0 is equals to c in bracket 1 plus 1. 1 plus 1 is a 2. Okay, that is a 2c is equals to 3. Therefore, c is equals to 3 by 2. Now substitute the values here, the value of c. Okay, this is the equation number 1. And after substituting, we will have this is the particular solution. What is that? 2 plus e raised to y is equals to 3 by 2 in bracket 1 plus x. Okay, next more simplification, which is the particular solution. That is a 2 in bracket, shift these 2 to the left hand side. Then you will have 2 in bracket 2 plus e raised to y is equals to 3 in bracket x plus 1. Solve the differential equation cos x into cos y into dy minus sin x into sin y into dx is equals to 0. Again here we will apply the variable separable form. Shift this term to the right hand side, it will become plus. Now which terms we do not require here? That is here we do not require here cos x, and what about here? We do not require sin y. Therefore dividing on both sides by, that is a cos x into sin y, or separate these variables. Okay. Therefore you will have cos of y upon, shift this sin of y to the left hand side into dy. Shift this cos x to the right hand side. That is, what is cos of y upon sin y? You will have integral of cot of y. Sin x upon cos x, you will have tan y. Integrating on both sides. Integral of cot y is nothing but log of sin y. Integral of tan x is a minus log of cos x. Also the constant in terms of log, that is the log of mod of c. Okay, shift this minus log of mod of cos x to the left hand side, it will become plus log of m plus log of n, that is the log of m into n is equals to log of mod of c. Taking the antilog on both sides or cancel log on both sides, then you will have sin y into cos x is equals to c. This is the solution. Next, find the particular solution of the differential equation dy by dx is equals to e raised to 2y into cos x when x is equals to pi by 6 and y is equals to 0. Now here dy by dx is equals to e raised to 2y into cos x, variable, apply the variable separable form, means transfer this e raised to 2y to the left hand side, it will become dy upon e raised to 2y is equals to cos x into dx. Now shift this to the numerator, it will become minus e raised to minus 2y into dy is equals to cos x into dx. Integrating on both sides, then you will have the integral of e raised to minus 2y into dy is equals to integral of cos x dx. Integral of e raised to minus 2y is e raised to minus 2y upon derivative of this minus 2y, which is minus 2. Integral of cos x is the sin x plus c. Okay. When x is equals to pi by 6, y is equals to 0. Okay. Now we are substituting. You will have, that is e raised to 0 upon minus 2 is equals to sin of pi by 6 plus c. What is e raised to 0? Is 1. That is the minus 1 upon 2 is equals to sin of pi by 6 1 upon 2 plus c. And hence here c is equals to minus 1 upon 2 minus 1 upon 2. Then you will have c is equals to minus 1. Okay. Substitute this value in equation number 1. Then you will have e raised to minus 2y upon minus 2 is equals to sin x minus 1. And multiply on both sides by 2. Then you will have minus, multiplying on both sides by 2, then you will have minus e raised to minus 2y is equals to 2 sin x minus 2. Okay. And after simplification, you will have e raised to 2y in bracket 2 sin x minus 2 plus 1 is equals to 0, which is the particular solution. Okay. Next, solve the differential equation dy by dx is equals to in bracket 4x plus y plus 1 bracket square. 4x plus y plus 1 is equals to u. Put here, differentiate. Okay, this substitution is very important. Derivative of 4x is 4, derivative of y is dy by dx, derivative of 1 is 0. And what about the u? Derivative of u is the du by dx. What is the value of dy by dx? Dy by dx is equals to du by dx minus 4. Now substitute here the value of dy by dx and 4x plus y plus 1. Okay, then equation number 1 become, that is du by dx minus 4 is equals to u square. Therefore du by dx, shift this minus 4 to the right hand side, it will become plus. Du by dx is equals to u square plus 4. Then you will have 1 upon u square plus 4 into du is equals to dx. Integrating on both sides, then you will have integral 1 upon u square plus 4 into du is equals to integral of dx. What about the integral of 1 upon u square plus 4? Is nothing but in this form. That is 1 upon a tan inverse of x upon a. What is the area? A is a 2. Therefore, you will have here 1 upon 2 tan inverse of u by 2. Integral of dx is x plus c1. Okay. And after multiplying on both sides by 2, then you will have tan inverse of u by 2 is equals to 2x plus 2c1. And next, substitute the value of u. That is the tan inverse of, in bracket, 4x plus y plus 1 upon 2 is equals to 2x plus 2c1. Okay. Replace the value of 2c1 by c, and hence you will have sums of tan inverse of, in bracket, 4x plus y plus 1 upon 2 is equals to 2x plus c. Now next, find the solution of this differential equation. Okay, that is a, or solve this. 1 plus dy by dx is equals to cos of in bracket x plus y. Here we have given the substitution. X plus y is equals to u. This question asked in March 24 examination. Now here 1 plus dy by dx is equals to cos of in bracket x plus y. Put here x plus y is equals to u. Differentiating. Then you will have derivative of x is 1, y is a dy by dx. Derivative of u is a du by dx. Now substitute these values. What is the value of 1 plus dy by dx is a du by dx. Therefore, you will have here du by dx is equals to cos of u. Again, apply the variable separable method. That is the du upon cosec u. Here, du by dx is equals to cosec u. Now, shift this to the left hand side. It will become du upon cosec u. Shift this dx to the right hand side is equals to dx. What is 1 upon cosec u? Is a sin u. Sin u into du is equals to dx. Integrating on both sides. What is integral of sin u? Integral of sin u is a minus cos u, and integral of dx is x plus c. Resubstitute or shift this minus cos u to the right hand side, it will become plus. Therefore, x plus cos u plus c is equals to 0. Resubstitute value of u, that is x plus cos of in bracket x plus y plus c is equals to 0, and hence this is required solution. Now we will see the example based on exercise 6.4. Example based on exercise 6.4. Now here, first example. Solve the differential equation dy by dx is equals to y plus in root of x square plus y square upon x. Okay. This example asked in March 14 and October 14 examination. Now dy by dx is equals to y plus in root of x square plus y square upon x. This first one. Put y is equals to vx. For this type of the examples, we take this substitution y is equals to vx. Differentiate this with respect to x. Therefore, dy by dx is equals to, applying here product rule, derivative of x is 1. 1 into v is v plus x as it is, derivative of v is a dv by dx. And this is the third one. Substituting the values of 2 and 3 in 1. Substitute the value of y is equals to vx. And dy by dx is equals to v plus x into dv by dx in equation 1. Then you will get here v plus x into dv by dx is equals to vx plus in root of x square plus v square x square upon x. Okay. And the next simplification, that is v plus x into dv by dx. From this root sign, we will take x square as a common. When x square is out of this root sign, it will become x. Again, from these two terms, take x as a common. Then in bracket, you will get here v plus in root of 1 plus v square upon x. Here x get cancelled. Okay. Therefore, you will get here v plus x into dv by dx. Then you will get here v plus in root of 1 plus v square. Now next, on both sides, v get cancelled. You will get here x into dv by dx is equals to in root of 1 plus v square. Now apply here variable separable method. That is dv is equals to in root of 1 plus v square, and shift this dx to the right hand side and the x also to the right hand side. Then after variable separable, you will get here dv upon in root of 1 plus v square is equals to dx upon x. Now here integrating on both sides, you will get here the integral of, what is the integral of 1 upon in root of x square plus x square dx, that is equals to log of mod of x plus in root of x square plus x square plus c. Okay, and hence you will have here log of v plus in root of 1 plus v square is equals to log of x is equals plus log of mod of 6, because all integrals are in terms of log, and hence we have taken this constant is also in the form of log c. Okay, this is the next. Now resubstitute the value of v. What is the value of v? V is equals to y upon x. Okay, therefore here we log taking the antilog on both sides. Then That is the log of mod of x plus log of mod of c is nothing but log of mod of cx. Taking the antilog on both sides, then you will have v plus in root of 1 plus v square is equals to cx. We substitute the value of v, which is the y upon x, in root of 1 plus y square upon x square is equals to cx. Now simplification. Now here the x square into 1, you will get here x square into x square plus y square upon x square. Root of x square is a x, therefore to the denominator you will get a x, therefore y plus in root of x square plus y square upon x is equals to cx. Okay, therefore after simplification you will have y plus in root of x square plus y square is equals to cx square. Okay. Now next, solve the differential equation in bracket x square plus y square dx is minus 2xy dy is equals to 0. This question asked in March 15 examination. Okay. Now rearrange these terms in this way. That is minus 2xy into dy is equals to minus in bracket x square plus y square dx. Now here again we rearrange the terms like this. Dy by dx is equals to minus become plus x square plus y square upon 2xy. Put y is equals to vx. Differentiate y is equals to vx with respect to x. Therefore dy by dx is equals to derivative of x. X is 1, keep v as it is, plus x into derivative of v is a dv by dx. Substituting the value of dy by dx in this equation, then you will have, that is the dy by dx is a v plus x into dv by dx. Okay, is equals to, what is next? X square. What is y? Y is a v square x square. Y is a v, vx, but y square is a v square x square. Take x square as a common, and to the denominator also x square. From the numerator and denominator x square will get cancelled. See this here. V plus x into dv by dx. If you take x square as a common, then in bracket you will get here 1 plus v square upon 2v x square. This x square and x square will get cancelled. Then you will get here 1 plus v square upon 2v. It implies that if you shift this v to this right hand side, then you will have x into dv by dx is equals to 1 plus v square upon 2v minus v. Okay. Therefore, x into dv by dx, that is 2v into v, then you will get here minus 2v square upon 2v. X into dv by dx, 1 minus v square upon 2v. Apply the variable separable method. Okay. Then you will have shift the term of v to the side of dv and x to the side of dx. Therefore, you will get here 2v upon 1 minus v square into dv is equals to dx upon x. Now integrate on both sides. Okay. Here. Integrating on both sides. Dx upon x. We have to adjust here minus sign in this bracket, and that's why here we are taking the plus, because the derivative of it is of the form, which is the form f dash of x. Okay, f dash of x upon f of x. Derivative of 1 minus v square is a minus 2v, and hence we are taking the plus sign. Now next, log of mod of x plus log of mod of 1 minus v square is equals to log of mod of c, and log of m plus log of n means of log of x into in bracket 1 minus v square is equals to log of mod of c. Taking antilog on both sides, then you will have x in bracket 1 minus v square is equals to c. Resubstitute the value of v, which is y upon x, and then simplify. That is x into 1 x square minus y square upon x square into x is equals to c. Then you will have x square minus y square upon x is equals to c, and the next x square minus y square is equals to cx, and this is the required solution. X square minus y square is equals to cx. Now next, solve the differential equation x square into dy by dx is equals to x square plus xy plus y square. Okay. Now again here, the first dy by dx is equals to, that is divide the whole equation by x square. Then you will have first here dy by dx, x square upon x square 1, xy upon x square, x z cancel, you will get here y upon x plus y square upon x square, you will have y upon x bracket square. Now put y upon x is equals to v. It implies that y is equals to vx. Now differentiate this again with respect to x. Same type of examples. Dy by dx is equals to v plus x into dv by dx. Now substitute here the values in equation 1. We get here, what is the dy by dx? V plus x into dv by dx is equals to 1 plus v square. 1 plus v plus v square. On both sides, we will get cancelled. X into dv by dx is equals to 1 plus v square. Okay. Apply the variable separable method. dv upon 1 plus v square is equals to dx upon x. Integrating on both sides, then you will have the integral of dv upon 1 plus v square is equals to integral of dx upon x. What is the integral of 1 upon x square plus a square dx is 1 upon a tan inverse of x upon a plus c, and hence here tan inverse of v is equals to log of mod of x plus c. Therefore, we substitute the value of v, that is a y upon x. Therefore, tan inverse of y upon x is equals to log of x plus c, and this is the answer. Now next, solve the differential equation x dot y into dy by dx is equals to x square plus 2y square, and the value of that equation y when x is equals to 1 is 0. Okay, now see this here. First, dy by dx is equals to, now here divide the whole equation by x into y. Therefore, you will have dy by dx is equals to x square plus 2y square upon xy. Okay, put y is equals to vx. Differentiate this with respect to x. Then you will have dy by dx is equals to v plus x into dv by dx. After substituting these values in 1, then you will have v plus x into dv by dx is equals to x square plus 2. What is y? Y is vx, v square x square. Again, x, y is a vx. Take x square common from the numerator and the denominator. Then x square will get cancelled from the right hand side. Okay, and the next also shift this v to the right hand side. It will become minus. Therefore, our new equation will be x into dv by dx is equals to 1 plus 2v square upon v minus v. Okay, next v into v minus v square. 1 plus 2v square minus v square. 2v square minus v square, you will get here v square. Therefore, 1 plus v square upon v. Okay, and the next, again apply the variable separable method. Shift this 1 plus v square upon v to the left hand side. Okay, now next is here dv by dx. Okay, after separating the variables, you will have v upon 1 plus v square dv is equals to 1 upon x into dx. Integrating on both sides, but we know here it is again of the form that is a integral f dash of x upon f of x into dx. Okay, but what is the derivative of 1 plus v square? It's a 2v. Therefore, we have to adjust here to the numerator and denominator 2. Okay, therefore 1 upon 2 log of mod of 1 plus v square is equals to log of mod of x plus log of mod of c1. Okay, see this here. That is a, therefore log of mod of 1 plus v square is equals to 2 times log of mod of x plus 2 times log of mod of c1. Okay, and next, that is a 2 log of mod of x means what? Log of mod of x square. Again here log of c1 square. But what is the log of c1 square? Here is the log of c1 square is equals to log of c, and hence it is written here log of mod of x square plus log of mod of c. Next, that is here the product of these two logs, that is the log of m plus log of n means what? Log of m into n means what? Log of c into x square. Now next, taking the antilog on both sides, then you will have 1 plus v square is equals to cx square. It implies that what is v? V is y upon x. Therefore v square V square means what? Y square upon x square. 1 plus y square upon x square is equals to cx. Okay. Now multiplying on both sides by x square, then you will have 1 into x square is x square plus y square is equals to c x raised to 4. Okay. Now for the particular solution, when x is equals to 1, y is 0. Then you will have x is 1, y 0, then c is equals to 1. Okay. Therefore, after substituting c is equals to 1 in 1, you will have the equation, that is a solution, x square plus y square is equals to x raised to 4, and this is the required solution of this is differential equation. Now next, solve the differential equation x into dy by dx minus y plus x into sine of y upon x is equals to 0. This question asked in March 24 examination. Okay. Yeah, again the dividing both side by x, then you will get dy by dx. We substitute here by x, x will get cancelled. Here you will get here dy by dx, y upon x plus. If you divide here x, then you will have sine of y upon x is equals to 0. Put y upon x is equals to v. Therefore, y is equals to vx. Differentiating with respect to x, we get dy by dx is equals to derivative of vx. X is 1 and derivative of v is a dv by dx. Therefore, dy by dx is equals to v plus x into dv by dx. Now, substituting these values, you will have here v plus x into dv by dx minus v plus sine of v is equals to 0. Plus v minus v get cancelled. X into dv by dx is equals to minus sine v. Okay. And after variable separable method, dv upon sine v means what? Cosec v into dv and is equals to minus dx upon x. Now integrating on both sides, that is integral cosec v into dv is equals to minus integral dx upon x. But what is the integral of cosec v? That is the log of mod of cosec v minus cot v is equals to minus log of mod of x plus log of mod of c. Okay. Now next, please substitute the value of v. Which is that? Y upon x. Therefore, log of mod of cosec y upon x minus cot of y upon x is equals to log of c upon x. Okay. Now here minus log of mod of x plus log of mod of c means what? Log of c upon x. Okay. Now next, taking the antilog on both sides, log get cancelled. You will have cosec y upon x minus cot of y upon x is equals to c upon x. Okay. Now after simplification, you will have multiplied on both sides by x. Then you will get the required solution. X in square bracket cosec y upon x minus cot of y upon x bracket complete is equals to c. Next, we'll see here the examples based on exercise 6.5. Now, example based on exercise 6.5. Now, let us start. First example, the slope of the tangent to the curve at any point is equal to y plus 2x. Find the equation of the curve passing through the origin. This question asked in March 13 examination. Let xy be any point on the curve y is equals to f of x. The slope of the tangent at point xy is nothing but it's a derivative dy by dx. Therefore, dy by dx is equals to y plus 2x. It implies that dy by dx minus y is equals to 2x. Means what? Shift this plus y to the left hand side. The given equation is of the form dy by dx plus py is equals to q, where p is equals to minus 1, q is equals to 2x. Now integrating factor is equals to e raised to integral p dx. That is a e raised to integral. What is the value of p? P is a minus 1. e raised to integral minus 1 dx, and therefore the integral of minus 1 dx is a minus x. Therefore, if is a e raised to minus x. Solution of the given equation is a y into if is equals to integral q into if dx plus c. Okay. Now here y into if is equals to integral q into integrating factor dx plus c. Here we substitute the value of integrating factor, that is a e raised to minus x. Y into e raised to minus x is equals to integral 2x into e raised to minus x dx plus c. Okay. Now here we will integrate this integration by parts. Here we have two functions. Okay. First is this is the algebraic and this is the exponential. Okay. Now integration by parts. First function means what? 2x into integral of the second dx minus integral derivative of the first into integral of second dx plus c. Okay. Now keep this as it is. The integral of e raised to minus x is a minus e raised to minus x, that is a minus 2x into e raised to minus x plus derivative of 2x is a 2. Integral of e raised to minus x is a minus e raised to x, and this minus sign, that minus and minus will become here plus 2 integral of e raised to minus x dx plus c. Okay. Next, what is the integral of e raised to minus x? Integral of e raised to minus x is a minus e raised to minus x. Therefore, overall you will have minus 2x e raised to minus x minus 2 e raised to minus x plus c. Therefore, you will have here y is equals to minus 2x minus 2 plus c into e raised to x. That is dividing on both sides by e raised to minus x. If we divide this whole equation by e raised to minus x, here e raised to minus x will get cancelled. You will get here y. Again, minus 2x into e raised to minus x, if you divide by e raised to minus x will get cancelled. You will get here minus 2x. Next, minus 2 into e raised to minus x, if we divide e raised to minus x, again you will get here e raised to minus x get cancelled. You will get here minus 2 plus c upon e raised to minus x. If you take e raised to minus x to the numerator, it will become plus, and then you will get here c into e raised to x. Okay, and this is the solution. Okay, number 1. But the required curve passes through the point 0 0, means what? It passes through the origin. Therefore, here we substitute x is equals to 0 and y is equals to 0. 0 is equals to minus 2 into 0 minus 2 plus c into e raised to 0. It implies that 0 is equals to minus 2 into 0, you will get here 0, minus 2, e raised to 0 means what? 1, that is c into 1 is a c, that is minus 2 plus c. Okay, and therefore c is equals to 2. Here the value of c is equals to 2. Substituting c is equals to 2 in 1, then you will get here y is equals to minus 2x minus 2 plus 2 into e raised to x, and hence we can write in this manner also. Therefore, 2x plus y plus 2 is equals to 2 into e raised to x, which is the required equation of the curve. Now next, solve the differential equation cos square x into dy by dx plus y is equals to tan x. This question asked in October 13 examination. Okay, now dividing the whole equation by cos square x, then you will get here, that is, if you divide here cos square x, then you will get here dy by dx, y upon cos square x, tan x upon cos square x. Okay, again dy by dx plus 1 upon cos square x means what? Sec square x into y is equals to tan x into sec square x. Okay, therefore this equation is of the form dy by dx plus py is equals to q, where p is equals to sec square x and q is equals to tan x into sec square x. Now integrating factor is equals to e raised to integral p dx, that is e raised to integral sec square x into dx. What is the integral of sec square x? Is a tan x, that is if is equals to e raised to tan x. Okay, now the solution of the given equation is y into if is equals to integral q into if dx plus c. Okay, therefore y into e raised to tan x is equals to integral tan x into sec square x into e raised to tan x dx plus c. Okay, now the next, see this here, y into e raised to tan x is equals to integral tan x into sec square x into e raised to tan x dx plus c. Now next, evaluate this integration. Okay, now see this here, RHS. Put tan of x is equals to t, then you will have sec square x into dx is equals to dt. Therefore, y into e raised to tan x is equals to integral t into e raised to t into dt. Now solve this integration by parts. Okay, see this here, y into e raised to tan x. Now here the first function into integral of the second. Here we will apply the Lie. Now here there are the two functions. First is algebraic function and the next is a exponential function. Therefore, first function into integral of the second means what? Integral of e raised to t is e raised to t. Here I will write here integral e raised to t into dt. Integral of e raised to t into dt minus integral derivative of the first function into integral of the second function bracket complete into dt plus c. Now next, what is integral of e raised to t? Integral of e raised to t is a e raised to t and the derivative of t is 1 and the next integral of e raised to t is e raised to t. See this here, y into e raised to tan x is equals to t into e raised to t minus integral derivative of t is 1, integral of e raised to t is e raised to t into dt plus c. Again finally, integral of e raised to t is e raised to t. Therefore you have y is equals to, therefore you have y into e raised to tan x is equals to t into e raised to t minus e raised to t plus c. Okay. Therefore y into e raised to tan x is equals to, we can take e raised to t as a common, then in bracket you will have t minus 1 plus c. Okay, and again it can be written as by substituting the value of t, which is the tan x. Therefore y into e raised to tan x is equals to e raised to tan x in bracket tan x minus 1 plus c. Now next, find the equation of a curve passing through the point 0, 2, given that sum of coordinates of any point on the curve exceeds the slope of the tangent to the curve at that point by 5. Means what? X plus y is equals to 5 plus dy by dx. Let xy be any point on the curve y is equals to f of x. The slope of the tangent at point xy is a dy by dx. Therefore, according to given condition, what is that? The sum of coordinates of any point on the curve exceeds the slope of the curve by at that point by 5. Means what? Dy by dx plus y is equals to x plus y, or x plus y is equals to dy by dx plus 5. Okay. Therefore, again, this can be written as dy by dx minus y is equals to x minus y. This is of the form dy by dx plus py is equals to q. Here p is equals to minus 1, q is equals to x minus 5. Okay. Now integrating factor is equals to e raised to integral p dx. But what is the value of p? P is a minus 1. That is equals to e raised to integral minus 1 dx. That is equals to e raised to minus x. Therefore, the solution of the given equation is, okay, solution of the given equation is y into integrating factor is equals to integral q into integrating factor dx plus c. Now substitute the value of if, which is e raised to minus x. Therefore, y into e raised to minus x is equals to integral. What is the q? X minus 5. If is e raised to minus x dx plus c. Okay. Therefore, after simplification, integral, that is x into e raised to minus x dx. Again, minus 5 in minus 5 integral of e raised to minus x dx plus c. Now solve this integration by parts. Okay, again here there are the two functions. First is here the algebraic function and the exponential. First function into integral of the second minus integral derivative of the first into integral of the second. And what is the integral of e raised to minus x? That is e raised to minus x upon derivative of minus x is minus 1 plus c. Okay, next simplification. That is integral of e raised to minus x is the minus e raised to minus x into x. Then you will get here minus x into e raised to minus x minus integral derivative of x is 1. Integral of e raised to minus x is the e raised to minus x upon minus 1 dx. Okay. And what about here? Minus minus will become plus. That is 5 into e raised to minus x plus c. Okay. And overall you will have minus x into e raised to minus x plus integral e raised to minus x dx plus 5 into e raised to minus x plus c. What is the integral of e raised to minus x? Minus e raised to minus x plus 5 into e raised to minus x plus c. And finally you will have y into e raised to minus x is equals to x in minus x into e raised to minus x. But what is simplification of this? This is a minus e raised to minus x plus 5 e raised to minus x. After simplification you will have 4 into e raised to minus x plus c. Okay. After dividing by e raised to minus x on both sides, then you will have y is equals to minus x plus 4 plus c into e raised to x. And therefore it can be again written as x plus y minus 4 is equals to c into e raised to x. But the required curve passes through the point 0, 2, and hence here we will substitute x is equals to 0 and y is equals to 2. After x is equals to 0, y is equals to 2, minus 4, c, x is equals to 0 means what? E raised to 0. And after simplification, you will have c is equals to minus 2. Substituting c is equals to minus 2 here, you will have the equation x plus y minus 4 is equals to minus 2 into e raised to x. Therefore, you will have y is equals to 4 minus x minus 2 e raised to x, which is required equation of the curve. Now next, solve the differential equation dy by dx minus y is equals to e raised to x. Hence, find particular solution for x is equals to 0 and y is equals to 1. Okay. Now, the given equation, it is of the form dy by dx plus py is equals to q. P is equals to minus 1, q is equals to e raised to x. Integrating factor is equals to e raised to integral p dx. E raised to integral minus 1 dx, that is equals to e raised to minus x. Integral of minus 1 dx is the minus x. Okay. Therefore, if is a e raised to minus x. Now, the solution of the given equation is y into if is equals to integral q into if dx plus c. Therefore, after substituting the value of if, that is y into e raised to minus x is equals to integral e raised to x into e raised to minus x dx plus c. Okay. And finally here, we will integrate this e raised to x into e raised to minus x. Then you will have e raised to 0. E raised to 0 means what? 1 dx. Therefore, again the integral of 1 dx is a x. Therefore, y into e raised to minus x is equals to x plus c. Okay, this is the first equation. When x is equals to 0 and y is equals to 1, we will find out the value of c. If we substitute x is equals to 0 and y is equals to 1, here y is equals to 1, x is equals to 0, x is equals to 0 plus c. What is the value of here c? C is equals to 1. E raised to 0 means 1. Therefore, you will have c is equals to 1. Substituting c is equals to 1 in equation 1, you will have y into e raised to minus x is equals to x plus 1. Okay. And again, it can be written as, that is, if you divide on both sides by e raised to minus x, then you will have y is equals to, in bracket, x plus 1, bracket complete, into e raised to x, which is particular solution. Solve the differential equation dy by dx plus y into sec x is equals to tan x. Again, the given equation, it is in this form, dy by dx plus py is equals to q. Here p is equals to sec x, q is equals to tan x. If is equals to e raised to integral p dx. That e raised to integral of sec x. But what is integral of sec x? Is a log of in mod of sec x plus tan x. And that is nothing but if is nothing but sec x plus tan x. That is e raised to log of mod of sec x plus tan x is nothing but sec x plus tan x. Okay. Now the solution of given equation is a y into if is equals to integral q into if dx plus c. Substitute the value of integrating factor, that is sec x plus tan x. Okay. Y into sec x in bracket sec x plus tan x is equals to integral q. What is the q here? Q is a tan x. If is a sec x plus tan x bracket completed into dx plus c. Okay. Now after multiplication, tan x into sec x and the next is the tan square x. Now integrate, that is sec x into tan x plus tan square x means what? Sec square x minus 1 bracket complete into dx plus c. Now next again y into in bracket sec x plus tan x. What is the integral of sec x into tan x? Is a sec x. What is the integral of sec square x? Is a tan x. What is the integral of 1? Is x. That is which is minus x plus c. Okay. And this is the required solution. Solve the differential equation in bracket x plus y into dy by dx is equals to 1. And therefore the equation can be written as dy by dx is equals to 1 upon x plus y. Again, it is written as dx upon dy is equals to, that is the reciprocal of this, is equals to x plus y. It implies that dx upon dy minus x is equals to y. Now here the variable is y. This equation is of the form dx upon dy plus px is equals to q. Here the value of p is a minus 1, q is a y. Therefore integrating factor is equals to e raised to integral p dy, that is equals to e raised to integral minus 1 dy is equals to e raised to minus y. Therefore the solution of the given equation is, okay, solution of the given equation is x into if is equals to integral q into if dy plus c. Here the variable is y, not that. Let's see this here. X into if. What is the integrating factor? Integrating factor is a e raised to minus y is equals to integral q. What is the q here? Q is a y. Okay, if is a e raised to minus y dy plus c. Again, x into e raised to minus y. Now here, integration by parts. Algebraic and exponential. First function into integral of the second into dy minus integral derivative of the first into integral of the second bracket complete into dy plus c. Okay. Therefore, you will have, what is the integral of e raised to minus y? E raised to minus y. Okay. Upon minus 1. That is overall, you will have minus y into e raised to minus y minus integral. What is the derivative of y with respect to y is 1. What is the integral of e raised to minus y? Minus e raised to minus y into dy plus c. Okay. And therefore, you will have here x into e raised to minus y is equals to minus y into e raised to minus y. And the next is here again. This minus minus will become plus. And again finally, the integral of e raised to minus y is a minus e raised to minus y plus c. And finally divide on again on the both side by e raised to minus y. If we divide, then here you will get a x, because e raised to minus y will get cancelled. E raised to minus y get cancelled. E raised to minus y get cancelled. You will get here 1 minus 1. And c upon e raised to minus y, if you take e raised to minus y to the numerator, it will become plus. Therefore, x is equals to minus y minus 1 plus c into e raised to y. And again, it can be written as x plus y plus 1 is equals to c into e raised to y. Now next, solve the differential equation dy by dx plus y is equals to e raised to minus x. Okay. Now again, this equation is of the form dy by dx plus py is equals to q. After comparing, p is 1, value of p is 1, q is a e raised to minus x. What is the integrating factor? If is equals to e raised to integral p dx. That is e raised to integral 1 dx is equals to e raised to x. Therefore, the solution of the given equation is a y into if is equals to integral q into if dx plus c. Y into if is e raised to x. Y into e raised to x is equals to integral q. What is the q here? E raised to minus x. If is e raised to x dx plus c. Overall, you will have e raised to 0 means what? 1. Integral of 1 dx. What is the integral of 1? Is x. Therefore, finally you will have y into e raised to x is equals to x plus c. And this is the required solution. Now next, find the integrating factor if of the given differential equation. Dy by dx plus y is equals to e raised to minus x. It's very easy. Okay, again it is of the form dy by dx plus py is equals to q. Here the value of p is 1, q is a e raised to minus x. Therefore if is equals to e raised to integral p dx, e raised to integral 1 dx. Integral of 1 dx is x. That is if is e raised to x. Therefore if is equals to e raised to x. This is the answer. And in this way, I have completed here the question based on exercise 6.5. Now the question based on exercise 6.6. Now board example based on exercise 6.6. These are word problems. Okay. Now here, first problem. A body is heated at 110 degrees Celsius and placed in air at 10 degrees Celsius. After 1 hour, its temperature is 60 degrees Celsius. How much additional time is required for it to cool to 35 degrees Celsius? This question asked in March 16 examination. Now the solution. Let theta be the temperature of the body at time t. According to Newton's law of cooling, d theta by dt is proportional to theta minus theta 0. Here theta minus theta, theta 0 is the temperature of the surrounding. We have given the temperature of the air is 10 degrees Celsius. Therefore, it implies that d theta upon dt is proportional to theta minus theta 0. Next, k is a constant of proportionality. Therefore, d theta upon dt is equals to k in bracket theta minus theta 0, where k is a constant of proportionality. Therefore, d theta, now variable separable method, d theta upon theta minus 10 is equals to k dt. Integrating on both sides, we get, okay, integral d theta upon theta minus theta, that is a theta minus 10 is equals to integral k into dt. What is the integral? Here integral is a log of theta minus 10 is equals to integral of k dt is a kt plus c, where when t is equals to 0 at the starting, the temperature of the body is 110. From this we will find out the value of c. Replace here theta by 110, that is the log of 110 minus 10 is equals to k into 0 plus c, and hence here the value of c is a log of 100. Now next, here the equation will become log of theta minus 10 is equals to, substitute the value of c, which is log of 100. Okay, therefore log of theta minus 10 is equals to kt plus log of 100, where next, when t is equals to 1, that is after 1 hour, the temperature is 60 degrees Celsius. Therefore, log of 60 minus 10 is equals to k into 1 plus log of 100. Okay, see this here. And after simplification, log of 60 minus 10 means what? Log of 50 minus log of 100 is equals to k. And therefore, log of 50 minus log of 100 means what? Log of 50 upon 100. Therefore, k is equals to log of 50 upon 100 is equals to, it implies that k is equals to log of 1 upon 2. This is the value of k. When theta is 35, then we have, that is the log of theta minus 10 is equals to log of. This is the value of k. We are substituting the value of k. What is that? Log of 1 upon 2 into t plus log of 100. Now replace here theta by 35. Therefore, log of 35 minus 10 is equals to log of 1 upon 2 into t plus log of 100. That is nothing but log of 25 is equals to log of 1 upon 2 bracket complete into t plus log of 100. That is, shift this log of 100 to the left hand side. Log of 25 minus log of 100 is equals to t into log of 1 upon 2. Then you will get here log of 25 upon 100 is equals to t into log of 1 upon 2. And here the simplification. Log of t is equals to log of 25 upon 100 means what? Log of 1 by 4 upon here this log of 1 upon 2. We are finding the value of t. Log of 1 by 4 is nothing but minus log of 4 with the help of the properties of the log. Log of 1 upon 2 is nothing but minus log 2. Okay. Minus minus will become plus. Log of 4 is means what? Log of 2 raised to 2. And next is here log of 2. Okay. Take with the help of the rules of log. That is the log of m raised to n means what? N into log of m. Here log of 2 get cancelled. Then you will get here t is equals to 2 hours. And therefore, the additional time required for the body to cool to 35 degrees Celsius is 2 minus 1, that is equals to 1 hour. And this is the answer. Now next, if the population of country doubles in 60 years, in how many years it will be triple under the assumption that the rate of increase is proportional to number of inhabitants. We have given the values, that is the log of 2 is equals to 0.6912 and log 3 is equals to 1.0386. Okay. Let x be the population of the country at time t. dx upon dt is directly proportional to x. Therefore, k is a constant of proportionality. dx upon dt is equals to kx. Where k is a constant of proportionality, dx upon x is equals to k dt. After separating the variables, integrating on both sides, then you will get here integral of dx upon x is equals to k integral dt. What is the integral of dx upon x? Is a log x. dt is a t, kt plus c. Okay. Now, next, see this here. When t is equals to 0, when t is equals to 0, that is the starting of the population, x is equals to x0. Therefore, we substitute the value, that is a log of x is equals to kt plus c. When t is equals to 0, x is equals to x0. Substitute here x is equals to x0. Therefore, log of x0 is equals to k into 0 plus c. It implies that c is equals to log of x0. Therefore, c is equals to log of x0. Therefore, substitute the value of this c in this equation. What is that? Log of x is equals to kt. Value of c is a log of x0. When t is equals to 60, the population is double. X is equals to 2x0. Now from here, calculate the value of k. Here, the replace x by 2x0 and the t by 60, log of x0 as it is. And the next, see this here. If we take log of x0 to the left hand side, it will become minus. Okay, see this here. When t is equals to 60, x is equals to 2x0, log of 2x0 is equals to log of is equals to 60k plus log of x0. Now next, therefore 60k is equals to log of 2x0 minus log of x0. Now here, with the help of the rules of logarithm, log of m minus log of n is nothing but log of m upon n. x0 x0 get cancelled. You will get here log of 2. Means what? 60k is equals to log of 2. Therefore, k is equals to here 1 upon 60 log 2. Okay, k is equals to 1 upon 60 log 2. Okay, this is the value of k. When x is equals to 3x0, that is what is the question? That is in how many years will it be triple? Therefore, we will write here x is equals to 3x0. Then we get log of 3x0. Substitute the value of x, that is a 3x0. kt, we have the value of k is also 1 upon 60 log 2. and log of x0. Okay, now substitute the values. Take this log of x0 to the left hand side. Substitute the value of k. What is the value of k? 1 upon 60 log 2. Log of 3x0 minus log of x0 means what? Log of 3x0 upon x0. x0 get cancelled. You will get a log of 3 is equals to t upon 60 log 2. Okay, and then hence the value of t is equals to 60 log of 3 upon log 2. But what is the value of log 3? It's a 1.0986 upon 0 point value of the log 2, that is 0.6912. And after simplification, you will have, with the help of the log tables, you will have 95.364. Okay, therefore after 95.4 years, the population of the country will be approximately triple, that is a 95.4 years. Okay, now next problem. The rate of growth of bacteria is proportional to the bacteria present. If initially there were 1000 bacteria and the number of doubles in 1 hour, find the number of bacteria after 2.5 hours. Here root 2 is equals to 1.414. Okay. Now the solution. Let x be the number of bacteria present at time t. Therefore dx upon dt is directly proportional to x. Therefore dx upon dt is equals to kx, where k is a constant of proportionality. Now separate the variable. That is the dx upon x is equals to k dt. Integrating on both sides, then you will have that integral dx upon x is equals to k integral dt. Okay. Now the integral of dx upon x is the log of x is equals to kt plus e. When t is equals to 0, x is equals to 1000. That is at the starting. When t is equals to 0, the bacteria was 1000. That is if we substitute x is equals to 1000 is equals to k, t is equals to 0, then you will have the value of c. The value of c is equals to log of 1000. Therefore, after substituting the value of c here, then you will have the new equation log of x is equals to kt plus log of 1000. Okay. Now next, this is the equation. When t is equals to 1, x is equals to 2000, because after 1 hour the bacteria doubles. Okay. Therefore, if we substitute here, the x is equals to 2000, that is the log of 2000 is equals to k into 1 plus log of 1000. We shift this log of 1000 to the left hand side, then you will have log of 2000 minus log of 1000 is equals to k. Therefore, what is the value of k? Log of, after using the rules of log, that is the log of m minus log of n is nothing but log of m upon n. 0 get cancelled. The value of k is a log of 2. Okay. When t is equals to 2 and half, that is a 5 by 2, then we get here, that is a log of x is equals to 5 by 2 k. This is the value of t here. Okay. Log of x is equals to 5 by 2 k plus log of 1000. Now the next simplification, log of x is equals to 5 by 2. The value of k is a log of 2 plus log of 1000. And next simplification, see this here, that is a 5 by 2 log of 2 means what? Log of 2 raised to 5 by 2 plus log of 1000. 2 raised to 5 by 2, log of 2 raised to 5 by 2 means what? 4 log of 4 root 2. That is a 2 raised to 2 into root 2. 2 raised to 2 means what? 4. That is a 2 is complete and 1 is half. Therefore 4 root 2 plus log of 1000. And this is again log of m plus log of n is nothing but log of m into n. That is equals to log of 4000 into root 2. That is a log of 4000 into 1.414. After multiplication, you will have, that is a log of 5656. Therefore, the value of x is nothing but 5656. Therefore, thus, there will be 5656 bacteria after 2.5 hours. Okay. And this is the answer. And in this way, we have completed the differential equation chapter. Okay. Now, We will see in the next video. Till then, goodbye.